particle of mass m slides without friction on the inside of a cone. The axis of the cone is vertical and gravity is directed downward. The apex half angle of the cone is theta, as shown in the diagram to the left, and the path of the particle happens to be a circle in the horizontal plane. The speed of the particle is v naught, and so draw a force diagram and find the radius of the circular path in terms of v naught, g, and theta. Okay, so here I have a cross section of the cone with the mass on the diagonal, and I'm going to draw the forces on the mass. So we have the force of gravity, and we have the normal force. So now we have to decide which component we want to break up. So as we know, the particle is going in a circular motion like this. And so if we break up the force of gravity, we'll get a vector pointing downwards and a vector pointing opposite to the normal force. Now that doesn't really help much because we are trying to find the radius. We're trying to find r. So I propose these two vectors. We call this ny and nx. Now as you can see, nx is equal to the centripetal acceleration of the particle. And the formula for the centripetal acceleration is mv squared over r. So now we want to find what nx is. Well, we know that ny is equal to mg because the particle is stationary in the y-axis. It doesn't move up or down. So let me just write that. Ny equals mg. And so what is ny in terms of n and theta? So if this angle is theta, then this angle also has to be theta because it is in series. And so if this angle is theta and this angle between the normal force and the cone is 90 degrees, then this angle right here has to be 90 minus theta. And so if this angle right here is 90 minus theta, this angle, then this angle right here has to be 90 minus 90 minus theta, because this angle adds up to 90 degrees. So 90 minus 90 minus theta is just theta. And so this angle here is theta. So if I just bring the ny here, I can see that sine theta is ny over n. Sine theta is ny over n. And so ny is n sine theta. Similarly, nx is n cosine theta. So now, find r in terms of v naught, g, and theta. So as we know, F equals ma. But for centripetal acceleration, the force is equal to the mass times v squared over r. And if F equals mv squared over r, then r equals mv squared over F. And the force should be the force pointing towards the center. So let me just write center to clarify that. So it seems that we already have everything. We know the force pointing towards the center, we know the mass, and we know the initial velocity. So R would be mass times v naught squared over n cosine theta. But if you recall, the problem says that we were supposed to find it in terms of v naught g and theta. So we have to get n cosine theta, or n in terms of n and g. So if we come up here, we can see that ny is n sine theta. That is also equal to mg, as we see up here. And so n sine theta is equal to mg. And so n is simply equal to mg over sine theta. And so r is equal to m times v naught squared over mg over sine theta times cosine theta. And so the m's cancel out, and we have r equals v naught squared over g tangent theta, because the sine theta comes up here. And that's your answer.